everybody. Thanks for coming. Welcome to Continuous Delivery NYC. Tonight we're going to be hearing from FireHydrant IO, who are going to be talking about GitOps, which is the new pattern, I guess, in how you do deployments these days, turning your deployments into code as opposed to just routines that you run. And before we talk about that, though, just talk a little bit about Continuous Delivery NYC. This is a meetup mostly from the community, for the community. Shopkeep, who is hosting it, is very interested in helping everyone in the community learn from each other, right? We learn from each other when we go to meetups, when we post on Stack Overflow, read on Stack Overflow, post on Medium, post on our blogs, and this is how we do it. So if you've got a story to tell, if you've got something you want to share with the community, come talk to me afterwards, because we'd love to help you do that, because this is how we as engineers learn from each other. And if you're not going to do it here, please, in another forum, share your knowledge. Don't just be a freeloader on the community and give back. So without further ado, I'll hand it over to Bobby from FireHydrant IO.
Yeah, so that's actually why I'm up here. Is I walked up to him right after another talk. I said, hey, can I speak at this thing? And that was a month ago. So it really is destiny in some ways. Great. So what we're going to be talking about is no big deal deploys to Kubernetes. And what I'm going to do is I'm going to pull up my remote here really quick, and we'll get started. I trust this computer. Yes. And then we can all judge the type of music I listen to. Dropbox will inevitably ask if you want to upload all your photos. And Keynote and play. There we go. All right, we did it. Great. So what are we talking about? A few things. I like to start off telling you what I'm going to tell you, and then tell you, and I'll tell you what I told you. We're going to talk a little bit about the deployment landscape to Kubernetes. We're also going to talk about how FireHydrant IO deploys and the reason why we use kind of GitOps for that. There will be a live demo, so please just start crossing your fingers for me now, because we're going to deploy FireHydrant.io live in front of you, and hopefully that goes great. So who am I? My name is Robert Ross. People like to call me Bobby Tables. If you're familiar with the XKCD comic, I am Bobby Tables pretty much everywhere. GitHub, Twitter, since this is a developer crowd. And a couple of places I used to work at. I used to work at Namely. I was there for a pretty good amount of time. I worked at DigitalOcean when this was the logo. I worked at Thunderbolt Labs, which was a consultancy, and 5 others that really don't matter. One-page resumes, right? I am the founder and CEO of FireHydrant.io. Disclosure, this is not a product pitch, I promise you. I told Daniel it won't be, but it is a good example of how you can deploy. We're going to use ourselves. So let's talk about the importance of reliable deploys. What does that mean? Reliable deploys prevent incidents in a lot of ways. So as an incident response tool, we need to make sure our deploys are very, very consistent. Because the reason for that is 80% of the time an incident opens, it's actually due to a deploy. And that's not us. It's not like 80% of the time we deploy, we break. That's not our case. That's based on third-party research. Google actually mentions this stat in their SRE book. Another gentleman, I can't remember his name right now, has also published some findings recently that 80% of the time is a pretty good number for when stuff breaks. So if that's the case, you do need a quick way to mitigate. And that might be rolling back for a lot of us. That might be rolling forward. Roll forward is when you actually just fix the code that's broken and then deploy again. And having a reliable deployment pipeline to make this happen is super critical for any company. Any company that's trying to exercise continuous delivery, which I imagine the people in this room are, really need a reliable deployment pipeline to do this. And since this is deploying to Kubernetes, let's talk about Kubernetes just a little bit. So Kubernetes objects, for the unfamiliar, they're represented in YAML. They can be represented in JSON, but who's going to write JSON? So this is a pretty simple example, not a full example, of a deployment file in Kubernetes. And the thing to keep in mind with deployment files is that they describe the desired state of your system. They're not this is the state, this is what I want to occur. And then Kubernetes is going to do its best. It's going to do its best to make sure that your desired state is met. So objects in Kubernetes, everything in Kubernetes really is represented as an object, a Kubernetes object. Deployments, pods, volumes, and actually in Kubernetes, even IPs are actually represented as an endpoint. You can actually do kubectl get endpoint, and you'll actually find IPs in your system as well. So really, these objects in Kubernetes are a really key part to understand how you can reliably deploy to these systems. But we're going to focus on this deployment type first. Now, Kubernetes has this concept called the Workloads API. If you play with Kubernetes, there's like the core version of Kubernetes, which is your services, your pods, things like that. And then there's the Workloads API, which is apps. And those are deployments, daemon sets, stateful sets. And a deployment is actually kind of a wrapper of sorts. A deployment on its own doesn't actually describe, it isn't the piece doing the real deploy of pods. It's kind of a wrapper around the other mechanisms in Kubernetes that deploy these things. Because what it does is it creates replica sets in Kubernetes, another object type. So when you actually create a deployment, if we're looking at the top of this graph, that deployment creates a replica set, and then that replica set creates a pod, and then that pod eventually makes its way down to an actual node, a VM. And these replica sets also have an ownership ref attached to them as well, which I'll show you here in a second. And another thing to keep in mind is that deployments took a little while to really be fleshed out. Kubernetes 1.9 is actually when deployments were marked as stable. So there was a couple of variations of deployments and these workload APIs before the Kubernetes team finally said, this is how we're going to deploy to Kubernetes. It really was a long time, many years before deployments actually landed in Kubernetes. Great. And Kubernetes deployments solve rolling out new pod specs. That's really their core functionality, is that if you change a pod in any other way, such as the image tag, your Docker image tag, an environment variable, volumes, resource quotas, all of those are part of your pod spec. And when you modify that, Kubernetes looks and goes, oh, you've changed the pod that I am deploying. I'm going to kick off a new rollout. They also solve rollback points. Because if you remember back to that diagram, it's keeping a version of every single deploy that you do. So the deployment at the top is saying, okay, you modified a pod spec, here's a point in time that you can now roll back to. Another deploy happens, now you have another version. And this is really critical because if you do come up to a point where you need to roll back, if you're not using something like a deployment in Kubernetes, rolling back can be a challenge. You would have to do your own whole world kind of solution, and who really wants to do that? Maybe some of you. And deployments create version replica sets, so I kind of led into this slide. But basically, a deployment is going to create a new replica set every single time you deploy. And the previous replica set is going to have its number of replicas set to 0. So what happens is that Kubernetes is going to say, okay, old replica set, I'm going to scale you down a little bit, scale the new one up a little bit, and then it's going to slowly tilt the bowl over until the new pods are all the way up. And we'll see that here in a few. Great. So let's look at this replica set. So this is another Kubernetes piece of YAML on the screen. You can see line 3, kind replica set. And you can see at the top there that I'm just doing kubectl get replica set in the ladder truck namespace, and then one of the names. Now the piece here that I actually want to focus on is the ownership references. This replica set, you can create these on your own. In Kubernetes, you can create these objects on your own. There's nothing really saying you can't do that. But you probably don't want to because then you have to manage a bunch of other stuff. So it's better to use a deployment. And that deployment, when it creates a replica set for you, it's going to mark it with an ownership reference. This is actually part of the Kubernetes spec. This is under the metadata key. So you can actually have any object in Kubernetes can actually be owned by something else. Kubernetes manages it most of the time for you, but if you're building like a custom solution and you need to track ownership of resources, this is actually the block that you can do it within. And you can add multiple ownership references in Kubernetes as well. Now, we'll take a look at FireHydrant's deployment manifest, or just a snippet of it. So this is a pretty simple version of our deployment. We are a Rails shop. And a couple of things about this manifest. You can see that our labels, we have app.kubernetes.io component Rails. These app.kubernetes, these are actually a standard labeling scheme provided by Kubernetes. It's a little known thing, but if you actually look up Kubernetes standard labels, you'll find a page where they have 7 recommended labels that you should be using for your deployments. And one of them is component managed by, and then the actual name. Kind of a pain to type out if you're using label selectors and things like that, but this is actually a recommended convention. A lot of open source tools are starting to use these labels as well, Istio being one of them. Another piece that we have here is the progress, deadline seconds, replicas, revision history limit, and a bunch of other stuff. But we're going to talk about these two. So replicas, if you're familiar, this is going to create 10 pods. 10 pods in Kubernetes for your pod spec, which is listed a little bit below. And another really interesting piece about the deployment manifest is the revision history limit. And this is what tells Kubernetes how many rollback points that it should keep. So let's say you deploy this for the first time, you're going to have 1 revision. You deploy 10 more times, you have 10, obviously. And then the 11th time you deploy, that first one, the very first one, is going to get garbage collected by Kubernetes. It's gone. It's a goner. So if you need way more revision history, let's say you're deploying 10 times a day, that's a lot of times, you may actually want to increase this number, because if you realize that, oh, we actually need to roll back to 3 days ago, I can't imagine a scenario where that would ever happen. But, you know, to each their own. Treat this number to make it your own. Okay. So again, controller revisions. They're part of the workloads API. So deployments, daemon sets, stateful sets. These are the 3 object types in Kubernetes that will actually create these revision points. And revisions are only created when you modify the pod spec. Again, when you modify an envar, an image, anything about the pod spec, that will trigger a new revision for you. And then the number of revisions stored do depend on that revision history limit. Now the really cool piece about revision history is that there's a kubectl command for that too. If you've ever ran just like kubectl, it's just getting bigger and bigger and bigger. It's getting really kind of crazy. But this is a really nice one, because if you need to find revision history for, let's say, a deployment, we can see up here kubectl-n ladder truck for the ladder truck namespace, rollout history for the type of deployment for the one called Rails. A lot to remember in that. And what Kubernetes will do is it will return all of the revision numbers available. Now, the change cause, this is a little interesting piece, a little hidden part of Kubernetes as well. There is actually an annotation you can add to your deployments, and it's the change-kubernetes.io/change-cause. And when you add that to your deployment manifest, you'll actually see it in this list. So if you're doing deployments from some system and you actually want to record what that deploy is for, you can actually use that annotation and it'll show here, which is great. But if you only have numbers, that's not valuable. So what we're going to do is we're going to ask Kubernetes, I want to see the revision with the number 227. So we can use that same command and make it even longer and do --revision equals 227. And then Kubernetes will actually spit out the pod template at that revision number. So this is actually from our infrastructure. Please don't try to hack us. These are real things. And so you can see that we have the pod template hash is up there, and that's actually one of the key things it knows how to store these pod specs, and every other part. So if you need to see what was deployed yesterday, you can actually do that rollout history, and then you can pick a revision number, and this is what you'll see. You'll see, okay, this was what the state of the world was at that revision, which is really actually very nice. Revisions are really, really key because they enable you to roll back a bad deploy quickly. There's another command that I did not list, I should have, which is you can do actually rollout undo in Kubernetes, and you can give it a revision number, and Kubernetes will go, okay, and it will push it back to a previous revision. So if you have a oh shit kind of moment, that's a really good command to know. There's a stored version of the pod definition that can be referenced later when things catch on fire. This is really the point I'm trying to make here, is that if you need to know what the state of the world is, these revision histories are really, really nice for that. Okay, so I taught you a little bit about Kubernetes. So how should you deploy? So one thing I'm going to say here, these three logos up here, I've done all three in a production environment. And there are a bunch out there. So if you're wondering, why isn't Argo CD up here? Or I met another gentleman who's in the room, Cirrus CI, why aren't you up here? I just don't have an opinion. I don't like going up in front of people and saying things when I don't have a real opinion. So that's why this is this list. So let's talk about Jenkins, the world's most advanced bash terminal. For like, what, 20 years running, something like that? Crazy. This is their logo still. So Jenkins is fine for simple deploys, honestly. All right, good. Nobody got up and walked away. That would have been a little hurt to me. So Jenkins to execute kubectl commands is okay in a lot of ways. You know how I know that? There's a lot of software out there that we're all using that deploys this way. It might be a bank. I would wager most deploys are actually run this way on Kubernetes. You know why? It's the simplest thing. It's the most natural transition. You just deployed Kubernetes. That is hard. That's a hard thing to do. And now all of a sudden you want to learn some other crazy system? No, I'm going to stick with kubectl. A kubectl command might look like this. You might build a Docker image in your Jenkins pipeline. You're going to do a Docker build. You're going to do a Docker push to a Quay registry or Amazon's or Google GCR. And then what you can do from there is you can run kubectl set image, and you can change your deployment to just be that new image you built. This is fine. I just deployed. The moment I run that command for my CI, I've deployed a new version of my code. That's pretty cool. That's pretty simple. One of the problems, though, is that that's always going to return a exit 0. So you don't actually know if it's done deploying and if you need to actually stop your CI. So Kubernetes has a really nice trick in it. You can actually do kubectl wait, and you can actually give it a resource inside of Kubernetes to wait for, and you can say for when the condition is equal to available. And this is really nice because if you need to block your CI from actually finishing, you can run this command, and Kubernetes will just sit there and wait. There is a little caveat down at the bottom there. This won't catch pods that didn't actually come online. So be careful. All right, second on deck. Now I have probably the most opinions about Spinnaker, actually. So let's talk about Spinnaker. It can do everything, literally everything. Like, there's nothing in your deployment pipeline that Spinnaker probably can't do. And if there is something that like Spinnaker can't do, I really want to talk to you, because like crazy companies are using this. Like this is how Netflix deploys. Google, a lot of Google, namely, I would know. I did it. Like it is a crazy product, and it has authentication baked in. Oh, you're using LDAP? Spinnaker's got that. You want GitHub authentication? Got that too. It's got a web UI. A lot of web UI. And one of the craziest things about Spinnaker to me still is that it's one of the few open source projects that I have found that uses microservices to deploy. It's not like a discourse, like little Rails app that like you boot and it's like, oh, I have discourse. It's like you have 6 or 7 different Java applications that you need to run to make Spinnaker like work. So it's super advanced, but it can do everything. That is one of the costs of super advanced things. The user experience of something goes down when something is very powerful. Look at Amazon Web Services console, right? That's a thing. So you're going to have fun setting it up. If you choose to go the Spinnaker route, have fun. I heard a couple chuckles. Trust me, this is not an easy thing. Like, I hope that you have a really stable relationship and maybe some alcohol and a shoulder to cry on. Because trust me, I gave a talk about this at Spinnaker Summit, and this is man, you can hear it in my voice. I saw some stuff. So it comes with steep costs. Spinnaker is a completely new tool that your engineering team will have to learn in order to deploy. And what I mean by this is that when we deployed Spinnaker at Namely, we had an hour meeting set up with every single individual engineering team. We didn't do an all hands, because when you're doing all hands, somebody's going to raise their hand, they're going to have a question, and you're going to answer that question, and now nobody else is going to ask that same question. So you don't know where your biggest questions are when you do a big all hands for a project like Spinnaker. What you need to do is break your organization up a little bit and introduce them just a little bit at a time. Because you're going to do this, and I promise you're going to get the same question from a couple of different teams. And now you know, based on that, oh, we got that question a few times. That's our biggest gap. So don't introduce something like Spinnaker at an all hands. Just don't. It won't work. It really won't. You have to introduce it slowly to every team, and you have to find champions within those teams. So that's a steep cost to start doing continuous deployment with Spinnaker. Let's go to number 2. It's very complicated to run and set up effectively, especially across multiple environments. You're going to have a fun time with that. Configuration is also very difficult to keep as code. There's actually no tools really supported by the Spinnaker team for keeping pipeline as code. Namely actually had to build our own. If you go to github.com/namely, most of the open source tools on the GitHub Namely are for Spinnaker, because it was just lacking a lot of tools to make it what we wanted it to be. You're going to have to get a dedicated team of at least 2, I guess that's like a duo, not really a team, to install and get going for your organization in a timely fashion. If you're running 20 plus microservices, you're not going to be able to install Spinnaker in a month. It won't work. You're going to need at least 6 months if you're a bigger org, which is what actually it took us to do. I'm not getting paid for this last bullet point. If you are interested in Spinnaker, if you are a bigger org, I don't know some of the people in here, if you're running 20 plus microservices, you need these advanced features I was talking about, but you don't have a team for it. Armory.io, they're a really good company, small little team. They are a managed Spinnaker consultancy, and they're super smart. They've done some really intense installations of Spinnaker out there in the wild. Okay. We're going to talk about our choice. This is probably why you came. You saw Kubernetes and no big deal deploys. Everything I just said was kind of a big deal. Now we're going to middle ground it. So Reflux. It is a GitOps Kubernetes controller. I'm kind of a Daniel. I don't really know what GitOps is. It's made up in a way, but basically the gist of it is you're controlling your deploys through Git, nothing else. It relies on a Git repository containing your configuration, and as we just learned, configuration is YAML in our world. It can watch a Docker registry for new images and apply those changes. So all you need to do is deploy a Docker image. Reflux will kind of take care of the rest. It can deploy any Kubernetes object. This is actually a huge deal. If you're doing Let's Encrypt using Cert Manager, which we're doing, or if you're doing Istio virtual services or anything else using CRDs, there's kind of an argument of it doesn't have to be a CRD. Flux is great because it's just YAML. You can just apply that for you. Okay, so this is what you do. This is what we do. It's what they kind of say to do. but we have a repository called K8 manifests on our GitHub org. And what we do is this is just a bunch of YAML. There's nothing else. And the way that we do it is we separate all of our environments by a folder. So we have a staging environment and a production environment. And what we do is inside of that folder, we have application names. So it'll be /production/ladder truck, and then config map, and then deploy web, deploy sidekick. And that's how we kind of organize all of our configuration for our application. So let's deploy it live. This is the part where I get a little sweaty, and not because it was 87 degrees out and I walked here up Park Avenue. So what we're going to do is we're going to bail out of here. We're going to bail out of here. There we go. And we're going to go over to my browser, and we're going to do nyccd do it live. So we're going to merge in this branch, and we're going to merge this. My co-founder said to do it to staging. Nah. Do master. Why not? Oh yeah. Oh, sorry. I forgot. I just got told. Okay. So we're looking at a. Oh, this might not be a good idea. That is a very different diff than what I had earlier. Hold on. Needs rebase. Let's go into staging. Yes. Okay, that's a little safer. Who knows what I was about to deploy? Because our deploys are so reliable, it just would have gone out. Great. So what we're going to do is we're going to squash and merge this. And our deploys take 6 minutes. About 6 minutes. 7:14 right now. So what we're going to do is we're going to go back. All I had to do was merge into our core Rails app. That's all I just did. All I did was merge a PR into a staging branch on our live application. It's going to go to staging. All right, let's go back to Keynote here. So this is how our system works. So you just saw me merge. Here's what is about to happen. Circle CI is going to run our tests. We have a pretty decent test suite. It's going to take a few minutes. And then what it's going to do is it's going to build a Docker image. And then what we're going to do is it's going to push that up to Google Container Registry. And here's how we format our tags. On Google Container Registry, this infrastructure-58C, that's actually the name of a project. That's just the way that Google Container Registry works. The part that we care about is this ladder truck :staging gibberish. Now, what that gibberish is the name of the branch and a SHA, the commit SHA. Now, this is a really important part because if you think about it, using that commit SHA in your Docker image is an extremely easy way to reference what code is actually running on production. We don't like doing latest. Semver breaks when you're deploying all the time. What are you going to have, like 1.0.5010? Like, it doesn't really work. So we tend to just use commit SHAs. It's a really nice point in time for us to use. Now the next thing that's going to happen is Flux. This is the first time we're going to hear about Flux. Flux is going to look for new images that were pushed up to Google Container Registry. It's just sitting there, just doing a loop every once in a while. It's going to be like, oh, a new one. And the next time that it finds that a new image, in our example, staging dash whatever it is, it's actually going to clone down that K8 manifest repository, and it's going to change that YAML file for us. So it's going to clone it down from GitHub, change the YAML file, and then it's actually just going to apply it to the cluster that it's running on. So the way that Flux works is it's actually sitting on your Kubernetes cluster. So if you have a staging, a production, and a QA, you're going to be running Flux 3 times. And then once it's done applying it to Kubernetes, it pushes that change up to GitHub. So I'm going to go back to my little remote over here. So Flux relies on annotations in your Kubernetes objects to perform its deployment operations. This is kind of one of the things that it's a little weird at first, I will admit. I was like, this is weird. Why am I putting deployment stuff in my YAML? But it actually makes a lot of sense. And for example, we need to inform Flux which images we care about. And we do that using this annotation. So this is an annotation you would put on a deployment YAML file, if you remember from the very beginning of our talk. And it's flux.weaveworks, the domain, /tag.rails, kind of weird, glob master-star. So this glob, it's not regex. This is a glob like if you're in a shell and you do ls/star, that's what this is. It does support regexes though, so if you need to find images in your registry based on a regex, you can do that as well. Any images that match this pattern on the registry will be registered for deployment in Flux. So if you think we're pushing up that staging branch, hopefully is working right now, and it's going to go up, and it's going to have that staging dash commit SHA, and our deployment file is going to reference that. So this is the infrastructure that, or I'm sorry, this is the Docker image that should be pushed up, and it's going to match on that highlighted blue text because of that glob. You see master-star matches that. Moving on. So that tag.rails is a little weird because .rails, Weave doesn't know anything about Rails. Why is that in an annotation? So the way that it works is that Weave is going to look for any annotation that starts with flux.weave.works/tag dot. And then it's actually going to use that dot syntax to find the container in your YAML to update. So if you look on line 34 there's a container in our pod spec called Rails. So we're telling Weave, okay, anytime an image with master-star is pushed for the Rails container, we're going to update line 35. We're going to update line 35 with whatever the newest image tag is. So if we click there, if we go to the next slide here, this is a screenshot from our GitHub repo of K8's manifests. And you can see that it was Weave Flux committed it on the left side there. And you can see that it actually updated our image line with the newest image that was pushed to production. So it's a really easy way to get auditability, deploy continuously, and have rollback points because you can revert a commit no problem. GitHub supports that in the UI, and it includes your username. A really nice solution. All right, moment of truth here. Moment of truth. We're going to go to staging, and I don't remember the name of the file. Please hold. Files changed. nyc-devops.html. Did it finish though? That's the question. Or I spelt it wrong. Let me just check if I spelt it wrong. nyc-devops.html. I did not. I merged it. So now what we're going to do is I planned for this. We're going to look for the pods that are running on staging. Please, oh please, oh please. Am I on staging? Yep, okay. Container creating 19 seconds ago. Ah. All right, let's check it out. Let's go back. How's everyone doing? Good day. This is the least amount of beer I've ever seen drank at a meetup. Is it because it's up here and I'm here? Like nobody wants to, yeah, there's a couple in. All right, let's check a little bit. Terminating, running. All right, let's see if we have it load balances. So we're going to see if we get new image. 1 minute. Now I'm starting to think I spelt it wrong. Come on. I know I didn't spell it wrong. I'm going to check anyways. We'll just do that. All right. Well, here's how I can prove to you that it worked. We have revision on the left side over here, AE 5E1, and if we go to this, committed 8 minutes ago. Okay, great. So deployed it, no idea why my image is not showing. Apologies for that. It was a big marquee tag. I wanted to troll everyone with a marquee tag. But what I wanted to show you last was our K8's manifests repository and what actually happened here. So if we go over to this repository, we can see that our staging had a change 3 minutes ago. And we can click on this. And this was Reflux updating it. So we can say we can see the SHA right here is AE5E711. And then if we go back to our branch for staging, we'll see that the latest commit here is AE5711. So it worked. We had a pretty simple way of deploying it. We have some simple YAML files that are configured. Reflux is kind of running, and to get Reflux running really is not that hard. So that is working well. So let's close this up. Simple, consistent deploys equals safer. I forgot to change the image. Deploying code should be the most boring part of your infrastructure. It really should. If it's a big deal to deploy, something's a little wrong. You should aim for boring deploys. Because when you have boring deploys, you'll do them more often. Using tools you already know, Git for example, makes the barrier to entry a lot smaller. You have a team of engineers do you really want them to learn a bunch of new tools just to deploy their code? No. If anything, you should want them to learn less, forget things, and then you'll have a much better deployment story. All right, so this is me. Thanks for coming out. Thanks for watching. A very attentive audience. I'm Bobby at FireHydrant.io. Honestly, hit me with any question you have. It doesn't have to be about this. If you want to talk about Istio, Kubernetes, anything like that, I'm up for it. And yeah, a couple questions.
Could you speak to some of the wins that Flux offers over, for example, having Circle apply your manifests directly to the cluster?
Yeah. So the question was, what are some of the benefits that Weave gives us over something like having Circle deploy it or Jenkins? Did I say that right? Yeah. So one of the advantages is that you have a commit point that you can roll back to, whereas with Circle you don't really in a lot of ways, because you would actually have to rerun your entire test suite to actually perform a rollback. So if you have a pull request that you're merging, nope, not answering your question. Okay.
I mean, you can use workflows to split up your jobs into multiple pieces.
Sure, which we do. So you're saying you can't roll it back, or you can?
I'm saying that is how we roll back.
Got it. You should show me, or speak at this meetup.
Okay.
Yeah.
Thank you. So let's say, so we got to the point, I guess, of getting the code into production.
Yep.
Right now, whether it worked or not, right? That's the next.
Yeah.
That's the next phase of validation, I guess you could say, right?
Right.
So now, in terms of the unbreakability of it, so when you're committing your code, it goes through the whole process, maybe probably putting some testing in there, and it gets out to production now. So is there anything in there where you're trying to do more in an automated fashion to now say maybe that if after 10 minutes you were still getting the 404, we'll do an automatic rollback or try some other things?
Right. So the question was like, let's say you push code out that makes it out but causes a problem. How do you detect automatically and roll that back?
Yep.
Did I say that correctly? That's a good question. So that's something that we've talked about pretty actively, and we've actually thought about building our own Kubernetes controller for this, mostly because we can detect when errors on our logs are increasing. We haven't really played with that. The way that I would do it, though, just what we've talked about is reverting the commit on the repo itself. Because when you revert the commit on the GitHub repo, Reflux is going to notice a change and then apply that new manifest. So you don't need to, that's one of the advantages of not having like rerun a workflow or something in Circle, is that you can just revert the commit and Circle and Weave will just take whatever it is. Any other questions? Thank you so much.
So thanks everybody for coming. Huge thanks to Bobby for the talk. That was a great talk. And big thanks to FireHydrant IO for providing the pizza. And I hope to see you again. We're having a good talk in September. It's not posted yet when Andreas Grabner from Dynatrace will be giving a talk about Kepton. But that's going to get posted soon. We're also still looking for a speaker for August. So if you're interested, let me know. And have a good night, everyone.